This is chapter 10. In this chapter, we will discuss two sample tests. Before, we were considering one sample test. When we were considering one sample test, our formula was x bar minus mu over s divided by square root of n. Now we are dealing with two samples, so now we will have x bar 1, x bar 2, and we will have mu 1 and mu 2, and our null and alternate hypothesis will be that both population means are equal, and we will say that both population means are not equal, and our formula will take the form likewise x bar 1 minus x bar 2 minus mu 1 minus mu 2 over something. We will see it in the next slides. So in this chapter we will discuss means of two independent populations, mean of two related populations. There is only a slight difference of the formula between these two topics. Then we will discuss proportion of two independent populations and variance of two independent populations. So when two independent samples are taken, we use a different formula for them. We will discuss it later, and here there are two assumptions which we made in case of two independent population samples. Like, what are those assumptions? We say that sigma 1 population standard deviation 1 and population standard deviation 2 are unknown, but we assume them that they are equal. This is called pooled variance t-test. We apply t-test here because we are dealing with two samples. Whenever we deal with two samples, we use t-test. Don't forget it. And when we say that sigma 1 and sigma 2 are unknown, like before, here is unknown, here is also unknown, but the difference is here we are saying that they are not equal. So we use a different formula for them. So when we assume them they are unknown but equal, we use pooled variance t-test. And when we assume them they are not equal, we use separate variance t-test. There is just a small difference in the formula. And one more thing, I should mention it here, that is our choice. We consider them equal or not equal. Otherwise it would be mentioned in the problem that assume sigma 1 and sigma 2 are equal or not equal. In both cases they would be unknown. So here is the null and alternate hypothesis. This one I have already explained. When we are dealing with two tail, we will say that there is no difference between two population means, and we will say that no, there is a difference between two population means, and this is one tail, lower tail and upper tail, like before we had. So everything is exactly same. This is the rejection region and exception region. Reject is not if the absolute value is greater than the critical. Okay, so these are the assumptions. We consider samples are independently drawn, normal population, sample size is at least 30, and population variances are assumed equal. So now coming back to the formula, which formula do we use in case of pooled variance t-test? Now we are considering this one. When we assume sigmas are equal, unknown and equal, in that case we use this formula. What is sp square? Sp square is this one. S1 is standard deviation of first population, first sample. S2 is standard deviation of second sample. N1 is first sample size, and 2 is second sample size. And rest of the things I think you know very well. And degree of freedom, in that case, you know, for t statistics we need degree of freedom, and in case of two sample test, this is the formula for degree of freedom. And similarly for the confidence interval, if we want to construct the confidence interval for two sample means, so this is the formula for constructing the confidence interval. Now we solve one example, pooled variance t-test. So here your financial analyst for brokerage firm, is there a difference yield between stock listed on NYSE and Nasdaq? Difference yield. So we want to test, is there any difference between two population means or not? We are given data. This is our N1, this is our n2 sample mean, this is x bar 2, this is x bar 1. It is not necessary that this is n1, you can consider this is s1 n1, you can call it n2 as well. So similarly, this is your s1 sample standard deviation and this is your second sample standard deviation. And difference, is there any difference between two populations? So this is, we say that yes, there is no difference between two population means, and alternative we say no, there is a difference between two population means. So test statistic, as I said, when we use two sample test, we use t-test, and this is the formula. Everything is given, we substitute all the values into this formula and we get t equals to this. Here you can calculate separately sp square, which we need to substitute here into the formula. So we get t equals to 2.040. We get t critical through the table. Degree of freedom is 44, n1 plus n2, n1 plus n2 minus 2. So degree of freedom is 44. You see the t critical value in the table, and then you can accept or reject h0. This is our t critical from the table. So likewise, we can construct the confidence interval as well. Everything is given, you have formula and you have all the values, you can substitute them and you can get confidence interval as well for pooled variance t-test.